or how an industrial framework or how a industrial operating embedded system will be, or what are all the simulators available for building up a robot. Let us say if I need to construct a robot which is of some 3 crores, before building that such a kind of robot I need to simulate it. So what are all the best open source softwares or simulators available for this kind of building robots and other technologies, what we need to consider while building up a industrial robot. Those are the things we are going to discuss. And is there anyone in this group aware of this robot category called swarmanoids? Yes, what is a swarmanoids? Yeah, as mentioned over there, to simply say, a swarmanoid is a singular group of robots which can either walk over, or it can either having hands to do some kind of works, or it can able to fly. That's a simple definition what we can say about swarmanoids. Before going into this session, let us see how a robot is being updated with much more artificial intelligence and all other categories. So let me see this small video. No need. Excuse me. I can't able to play the video over here. No. Yeah, a small technical fault over here. You just see this video, you can able to get a basic idea about what is a swarmanoid, and then we can go into the session. Can we give audio? I have given.
Environmental information to the other robots. In this film, the swarmanoid is deployed to find and then retrieve a book. Here, the swarmanoid has already partially explored its environment. As the iBots search, successive iBots attach to the ceiling, forming a connected network. Once an iBot has found the book, the knowledge propagates back to the deployment area. The handbot then requests transport assistance from the footbots. Using the iBot network, the footbots form a ground-based chain linking the deployment area to the book. The composite footbot-handbot entity then follows this ground-based chain. A second handbot prepares for transport. The first footbot handbot entity has rotated and aligns with the bookshelf. While climbing, the handbot supports its weight with a cord attached to the ceiling. Actuated fans give the handbot control over its angle of rotation around the vertical axes. Swarmanoid is a parallel distributed system. Parallel activity and redundancy increase its robustness and flexibility. The second footbot handbot could retrieve another book or act as a backup should the first footbot handbot fail. In this film, the Swarmanoid retrieves a single book. However, the true value of the Swarmanoid concept would manifest itself in parallel task execution scenarios and in unstructured environments. Future incarnations of the Swarmanoid might be able to replace human workers in hazardous environments, perform search and rescue missions, or even conduct exoplanetary exploration.
Okay, thanks for watching this video. And when you see this robot demo, you can come across some 5 points which is very much important for a robot. That is nothing but some kind of architecture what is need to be built, and some kind of protocols where it gets to communicated, and some kind of frameworks for what it is going to build up, and some kind of what to say, sensors or whatever it may be, some IOs. And before building up this kind of robot, it has to be tested. So we are going to have some simulators for testing. So these are the things we are going to see. As we say, is robotics in industries and protocols and RTOS and simulators. Okay, and building up a robot for fun, or building up a robot for some research purpose, or building up a robot for some kind of consumer based applications is well enough to do with the open source. But is it really necessary to go for a business model or to make the robot commercially available with the implementation of open source? If we come across that question, I would easily say yes. The main thing is the production cost, or the software what we are getting from the proprietary persons, it's quite higher for a middle and a lower end application. I am not speaking about a higher end robots or any other very particular industrial kind of things, and I am speaking about the low and middle end automation or industrial areas. Okay, so why? Because nowadays big companies like IBM or Google or even Facebook are now shifting over their sector into open source, and they are giving up many frameworks and simulators to and testing tools to build up. So they are surviving, or they are forced to get survived with the invasion of this open source technologies. So I thought, why can't we do this same for the industrial things also, and that's how I got this idea. So now let me see one by one what are all the architectures presently available for building up, or what are all the frameworks which is presently available for building up, or what are all the RTOS, or what are all the simulators available. And at the end I will just give you a sample running of some simulations. Okay. And when we speak about architecture, we have to consider both about the hardware and the software. So the best software architecture for building up a network based thing is OpenSDN, and where SDN defines software defined networking. I hope IT guys have heard of this word. And before going to that, can I know How many of you are purely IT here? And how many of you are from purely robotics side? Or how many, is there any specialized people in industrial robotics over here? Okay, or a mixture of both IT and industrial works. Is there anybody? Oh, good. So I hope some countable numbers are there, so it's very easy to proceed. And if you have any doubts in regarding this kind of things, you can either stop me in the middle, or at the end of the session you can ask the doubts. And when you consider this OpenSDN, there are many other networking things available, but why I choose this OpenSDN architecture to propose in front of you is that it has a very good software abstraction layer, which is with that you can easily access your OSI. And as you see in the demo, there central iBot is being controlling all the other robots which is moving over there. So there should be a centralized controller that should monitor all the other things. So this networking architecture is very much suitable for building that. And next is hardware architecture, and I came across this recently. Its name is Quanser. It's 6 DOF. What is meant by DOF in robotics? Degree of freedom, right? So in this Quanser, you can build up a robot up to 6 degree of freedom. And what is the speciality of this Quanser is that it is very much useful for creating this bilateral teleportation. Have anyone come across a concept called configurable robotics? I hope you all did not know this term technically, but if I say the film Transformers, you can able to come up with the name called configurable robotics, where the Bumblebee or Optimus Prime can shift into a truck or a car and then to robot. So similarly, this configure robotics is usually used to coin a term, or which is used to define a term as you can able to change over its shape or the way in which it's working. Okay, like if it is working as a robotic arm, then later it can be split up and work as a 2 mini movable robots or something like that. So Quanser is one such architecture where we have a full suite of features to go with. And next one is the frameworks. And when we speak about the frameworks, can anyone guide, IT guy can explain me what is the difference between an operating system and a framework? Yeah.
Yeah, so framework is actually a tool or a set of tools or a set of libraries which is running above an operating system, which is giving the developers some freedom and guidelines to implement things, and which gives the chance to speed things up.
Yeah.
Frameworks like Qt, for example, is one framework.
Or a .NET or something like that. Okay. Then operating system.
The operating system is a piece of software which is running on the hardware, which controls the hardware resources in the minimum configuration, at least memory and the time of the CPU is shared among different processes.
Sure.
This is minimum.
Okay, thank you. And as our friend rightly said, we can define an operating system as a software infrastructure component, like it is built up with a number of frameworks, or when we say about frameworks, we can say it up as a redesign or a reuse design component of operating system. Okay. So when you speak about this framework, many will think that framework is nothing but a blank. I'm not saying about the IT guys, I'm saying about the non-IT guys. Let us say people from electrical or mechanical. What they will think that when they Google up and when they see some information about frameworks, they will misunderstood that framework is an empty operating system. So to eliminate that thing over here, I asked my friend to explain. And out of the frameworks, the robot framework by the company robot framework is a very good one, and it is very, very good for acceptance testing. What is acceptance testing in IT, or user acceptance testing in IT? Can anyone answer the question? What is meant by UAT or AT?
Provide it to customers who validate and say they'll accept the product.
Yeah. So before when we are going to implement any product, it has to be checked or evaluated that whether it is meeting the requirements. So this robot framework is very essential, or it is very good for testing or acceptance testing. Okay. And the next one is robotium, and I hope some of the people over here building up the robots with Android can come across with this thing, robotium. Robotium is very good, or it is used mainly for creating a native hybrid UI applications, like when you are connecting your Android mobile phone with your Arduino Duo or Arduino Mega, and you are establishing a ADB driver and you are writing up some applications, or you are contacting this robot remotely with Wi-Fi with some apps, with those kind of things, or you are porting this Android operating system itself as a for some kind of applications in the robot using some high-end ARM9 or a Cortex-A8 processors. We can use this. And when we speak about the industry, we have to say something about the automation for what these robots are being used of. So when we speak about the automation frameworks, one of the best framework is this 4DIAC, and this 4DIAC is basically you can build up this 4DIAC suite with the IDE Eclipse. I know you are all very well known this IDE Eclipse, where you can develop your Android and Java applications. And this is how, or a screenshot of this 4DIAC, where you can have your robot controller being connected with some kind of motors or any sensors and all those things, and you can evaluate the entire system. And when you speak about the next automation framework, this is my favorite framework which I have been using in my company for more than 3 years. It's OpenMUC, and this OpenMUC is nothing but if you have come across some industries like process control, let us say a Coca-Cola bottling factory, or let us say a Lux soap manufacturing factory, where a repeated process is going over there, or in cement factory, or whatever it may be. Those areas, there will be two protocols named protection protocol and control protocol, and all those were still available in proprietary mode only. Either you can get from big players like ABB or Siemens or Rockwell or Honeywell or Delta or whatever the company is. But these were the very first people to introduce with the open source license that substation protocol IEC 650 and the SCADA protocol IEC 60780, and also this PLC IEC 61131. And in this IEC 6950 is there, and there are some other bus like Modbus or any other MBus RF, or you can even use Zigbee or 6LoWPAN with this. And when you say about the protocols, what we are going to use, it's similarly like some kind of communication mode or set of rules which is being present between the sender or any other FTP or TFTP or whatever it may be. It uses almost all the layers. But when it comes for the industry, it has only 3 layers, and the two only physical data link and application, and only you are going to use these 3 layers, and this all the other layers are being combined with the application so as to make the data transfer very, they have transferred like this. And I hope it's quite difficult for you to view in this. It's a comparison of all the other protocols which is being used in the industry. Of the best is ControlNet, DeviceNet and Profibus. And how many of you know Profibus here? Okay, Profibus is nothing but it is explained as process field bus. It's developed by Siemens, and in this process field bus you are having 3 categories, and out of those you can use Profibus FMS, like a field messaging service. That thing you can use for robotics, and other things are known by you, CC Link or EtherCAT or Modbus RTU. Modbus RTU is nothing but the RS-232. And this is a small example of how I implemented this OpenMUC framework into an embedded system and how I attained some kind of alarm or trigger from my system. Okay, so for this I used Android. In this I used the already available application called scripting layer for Android. It is nothing but it provides a scripting layer for various languages like Python, Java and Ruby. So I just choose the interpreter for creating my Python scripts, and I use open source package creating manager called Gradle. I hope you all know Gradle. With the Gradle package creator, I imported all the OpenMUC libraries and I compiled up. So this is my hardware setup having a Citara processor board, and along with this I have two 8051 boards being and this is my Arduino Mega and Arduino Uno which has a USB capability, and this is my block diagram of this hardware. So this is the app I created for this controlling, and when I execute my application I will be having some options over here like visualize screens where I can have some facilities to view my log or data or whatever it may be, and I have an alarm acknowledgement, and I have an audit like when and all I control my device with this app, and I can know the status and the information, and I can stop my thing. It's like a simple SCADA. And in this, if I notice some kind of alarm activation, I can view that I'm sorry, this graph is not visible here. This yellow curves present over here and the red curves present over here are the VI of a motor. And with this alarm, I got what are all the alarm and what is the value of that and at what time I got it and everything. And when I acknowledge the alarm, it's being recorded or it's being logged in the audit trail. So speaking about the RTOS, I think I no need to explain much about what is meant by RTOS or other things. It's a real-time operating system which is being ported into any kind of embedded systems for doing a specific kind of work or a single application. And there are some constraints while choosing a RTOS. I think you all know about these things. And when I come across which are all the best operating systems for the robot, I came across this one we are using for the past 9 months is robot operating system, and robot operating system is the best open source operating, and you can add the package to that and you can do whatever you want. And this is the special package which is present in the operating system called ROS Industrial. And the difference between the ROS Industrial and the ROS operating system is only this industrial eccentric calculation. It's nothing but it's a special package added to the ROS just for calibrating the 3D and 2D images. And I have a video, but I think I don't have time to play this. And the next RTOS is the Chibi OS. It is well suited for the well-known STM32 controllers. So I hope you know about this Chibi, and it is one of the only RTOS available at present which has almost all the interfacing capabilities and drivers and header files. And this is the compilation and a small demo created with this. And some of the other notable RTOS are the free RTOS or the TI RTOS and Stella or MicroOS and your own customizable thing. And when you speak about the simulators, these are the notable simulators available for modeling a robot, and out of this the colored ones like Microsoft Robot Development Studios and Gazebo, Anvil and RobotSim are best known simulators. Gazebo is mainly used for modeling a 3D kind of robot which is intended for locomotion like movable robots. like something like this. You can create many environments over there, or you can create some working obstacles and all those stuffs with this. And Anvil is a similar kind of simulator where you can able to trace the characteristics of the movement, or if it has any stone and if it is going over there and it has some jerk, what is the vibrational level and all those things. You can add virtually some kind of sensor with this robot and you can proceed with this. And Morse is another one special kind of simulation software. You can do all kinds of robotic arm, or you can do all kinds of visualization, and the main motive of adding this video rather than the other simulators is that it has some inbuilt sensor capabilities and you can view that, and up to this tier 2 virtual robot you can simulate in the. And it is one of the only one open source simulator which has a human avatar interaction. You can add a human itself into that. Other simulators which is available just will have a on-click functions only. And you can have some multi-node output. Possible to view over there is the 3 robots moving as well. And if you go to the site, you have a flying cat and mouse where you can program this mouse so that this cat will follow upon that. It's basically coded with Python. It's very easy to use also. And coming to the end of the session, I hope I have give some exposure or some values to or some ideas of creating this open source robot, and I wish you to show only one demo of one simulator. And it's called I can't able to view the simulator. I wish to show a demo over here of a simulator for a few seconds, but it's not viewing in the screen. The close பண்ண வருமோ the close பண்ணலாமா robot analyzer simulator you have a 3D model window and a graph window, and here you can calculate the forward kinetics, inverse dynamics and inverse kinetics and forward dynamics, everything, and whatever the links you have created you can able to view with this. And here you can select the degree of freedom and robot, and you can here set up the joint number, joint offset, angle, everything, and here you can configure your link. That is, let us say if I am going to connect my link 1 with the base frame, and if I am updating my entire status is being updated, and if I am going to calculate my forward kinetics, its analysis is complete, and if I play this I can view how a robot will act as per the inputs I gave here, and I can see the reverse action also. And in this, if I have some 5 joints, let us say example joint 2 and 3, what is the relative curve between the joint velocity and acceleration? I can calculate over that in real time, and I can see about the links, that is the axis, everything, and even I can have some more robots to show you. Okay. Let us say I have a simple one. Okay, this is a simple joint. For this I am again I'm going to link with the frame and updating. This time I am calculating my, okay, sorry. This time I am calculating my inverse dynamics and something happened over there. So nothing is happening here. So this simulator robot analyzer, you can use it for analyzing the joints and movements of a robot, and similarly there are the other simulators which I showed you. And that's all the end of the session, and it's time for queries. You can ask questions to me if you have any. Okay, I will be present over here till evening. You can ask any question regarding this industrial robotics, and thank you for attending the session.